And now we are going to solve this huge matrix equation for matrix X. Hi again, this is Fernando, welcome to my channel. Today I want to give you this big matrix equation. Please don't be scared because it's simpler than it seems. You can see that the thermometer is in green color, so it means that we are facing a typical exam exercise. Congratulations.
Binnacle project.
Well, let's copy the equation. It says matrix X plus matrix A squared equals matrix X squared plus X times A plus the order 2 identity matrix. Order 2 identity matrix 1, 0, 0, 1. But the most important thing is this one. Do you think that it's correct to open this parenthesis on this way? X squared, the first one squared, plus 2 times the first one times the second, plus A squared. Do you think it is correct? Of course, it is not correct. It would be a very big mistake to open the parenthesis on this way. What are we going to do? Let's apply the definition of power x plus a multiplied by itself, x plus a. And let's go ahead. X times x, x squared. X times a, x multiplying a. And now, a multiplying x, a multiplying x. And a multiplying a is a squared. And you already know that in this topic, x times a is not the same as a times x. The old commutative property doesn't exist in matrix operations, okay? So what we are going to do is to copy this structure, x squared plus xa plus ax plus a squared equals x squared plus x times a plus the identity matrix. And now look carefully for this structure, and you can see that we can cancel this term because it's in both members of the equation. But not only that, look, this is also the same term, so we can cancel out in both sides. So finally, this is the equation that we have to solve for matrix X. And you can see that it is luckily very simple, right? This is the most important thing that I wanted to tell you through this exercise. In matrix operations, it is not correct to open parentheses on this way, but we have to open it using the definition of powers. So now let's go on. What are we going to do? Let's pass this matrix to the right side. A times x equals the identity matrix minus a squared. Easy, right? And now look carefully that as matrix A is on the left side of x, we are multiplying both sides of this equation by the inverse of A. A inverse times A times x equals the inverse of A multiplying the right side, identity matrix minus a squared. And why did we do that? Because do you know that matrix multiplying by its inverse is equal to the identity matrix? This is the identity matrix. And the identity matrix multiplying x is x, okay? And there you have the solution for our matrix. And what are we going to do now? Well, we are going to calculate the inverse of matrix A, we are going to calculate A squared, and we will have the solution for this huge equation. As I ran out of space with the whiteboard, but here you have the result of the previous calculations. Now we are going to calculate the inverse matrix of A. There you have matrix A, 1, 2, -1, 0. And what is the formula that we're going to use to calculate its inverse? Well, the so-known adjugate matrix of A, but transposed, divided by the determinant of A. And I like beginning with calculating the denominator of this matrix, because you know that if this determinant equals 0, it would mean that our matrix A doesn't have inverse, so the problem wouldn't have solution. But in this case, you can see that the determinant of A is 1 times 0 is 0, minus -1 times 2 is -2. 0 minus -2 is 0 plus 2. 2. This is the value of the determinant. And now let's calculate the adjugate matrix of A. Can you remember that when calculating these positions, the first one, let's eliminate row 1 and column 1. Row 1 and column 1. 0. Now let's calculate the second position. Row 1 and column 2. Row 1 and column 2, -1. Third position, row 2, column 1. Row 2, column 1, 2. And finally, row 2, column 2. Row 2, column 2, 1. Do you think that these are the adjugate matrix? I'm afraid it is still not. These are the complementary minors. For these complementary minors to become the adjugates, we need to use the snake. Positive, negative, moving as a snake. When you say positive, it means that the number preserves its sign. But if you say negative, it means that we have to change the sign. Okay? Let's do it. Positive, negative, positive, and negative. Now these are the adjugates of matrix A. Now it's time to write the solution, and let's write this matrix, but let's transpose it. Please don't forget this little big detail. So row 1, 0, 1, but turn it clockwise in the form of column 0, 1, and -2, 1, but in form of column -2, 1, divided by 2. So our inverse is 0 divided by 2 is 0. -2 divided by 2 is -1. And there we have 1/2 and 1/2. This is the result of the inverse of A. Now it's time to calculate A squared. How are we going to do it? Well, if you want to calculate A squared, I'm afraid it is not possible to square these 4 positions. It would be a very big mistake. It is necessary to multiply matrix A by itself 2 times. That's the correct way. Let's do it. 1 times 1 is 1. 2 times -2 is -2. 1 minus 2 is -1. Okay? Second position. 1 times 2 is 2, and 0, 2. Third position. -1 and 0, -1. And the last position, -2 0, -2. This is a squared. And finally, we can put the solution because we are finishing this exercise. Matrix X is equal to the inverse of A. There you have it. 0, -1, 1/2, and 1/2. Multiplying the order 2 identity matrix. 1, 0, 0, 1 minus A squared. There you have it. -1, 2, -1, -2. Let's subtract these two matrices, and we have 0, -1, 1/2, and 1/2, multiplying 1 minus -1 is 1 plus 1, 2. 0 minus 2, -2. 0 minus -1 is 0 plus 1, 1. And 1 minus -2 is 1 plus 2, that is 3. And there you have the solution of this equation. We just have to multiply these two matrices, 0 and -1, 0 and -3. 1/2 times 2 is 1. 1 plus 1/2 is 3/2. And finally, 1/2 times -2 is -1. -1 plus 3/2. -1 plus 3/2 is 1/2. Use your calculator, and this is the final result. The most important thing that I want you to learn from this exercise is that it is not possible to open this parenthesis using old songs. It is necessary to use properly the definition of power. If you came here directly from the beginning of the exercise, from the statement at the beginning, I hope you got it right. And if you followed me during the solution of this exercise, I hope you've understood the setup and the solution. Congratulations, because you are doing the most difficult exercises in this topic. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!